Hello, this is Dr. Christy Patton-Lukes, a chemical engineering professor at Missouri S&T. In this lesson, we'll be looking at ways to model absorbers and strippers in AspenPlus. Now, you'll recall from class that we define an absorber to be a device or a piece of equipment that removes one or more components from a gas by absorbing it into a liquid solvent. And we define a stripper as one where we're going to remove one or more components from a liquid by mass transfer into the gas. And the point of view of the language is always that of the liquid phase. Now, the operation of both these will be the same. And so if you don't want to have to worry about which you're talking about, it's frequently convenient to call them both scrubbers. So we'll adopt that language. If you want to look at using a column for a scrubber and one that was being used for distillation, they really would look pretty much the same. In fact, visibly the only difference to the column itself would simply be that in a scrubber you always have two different feed streams, one at the top and one at the bottom. And in a distillation tower you could have any number of streams and they could, come in at any point in the tower. The real primary difference is going to be in the peripheral equipment. For distillation, I have to have a reboiler and a condenser. I may need pumps or other energy and flow management devices. But in a scrubber, all I need is the tower itself and the two feed streams and two product streams. So we're going to be looking at how we can use RADFRAC in AspenPlus to model a scrubber. Now we're going to do this. The problem I selected was one where a reactor takes in ethylene and oxygen and produces acetic acid, but there's also some waste materials, and the oxygen was brought in as air, so you're going to end up with a little bit of CO2, some nitrogen, some excess water, and then of course our product, acetic acid. So we're going to start our simulation by entering the components CO2 into acetic acid and water. And if we come to our methods, we're going to enter NRTL as our method. But now this is going to be where we do something a little different, because I know that CO2 and N2 should be non-condensable. I don't expect those to be found in the liquid phase. They're only going to be in the vapor phase. So I'm going to specify them as Henry components. You do that by saying new and then typing in a name for the Henry component. And you can name these anything you want, but it is convenient to use the name of your chemical itself. Now, at this point, the Henry's components now have kind of messed up the components list. That went from being a blue check mark to red. And if we look at the Henry's components, now then I can see that for the CO2, I'm going to model it here, and nitrogen, I'm going to model that one here. Now we see that, okay, these are all blue, but now methods is back to being red. And so we want to look at our parameters. We want to make sure that all of our binary interaction parameters have now been populated. And in this case, it's the Henry's law components. Okay. And you can use these. If you have better data, you could go in and change those. But I'm happy with those results. Let's move on to our simulation. So we're going to be adding two feed streams and we're going to need two product streams, and we're going to have a column, and we want to use RADFRAC. So, and before I do that, let me just say that RADFRAC, let's make a choice here. Look at all these different images we can use. It doesn't change what goes into the math, but it mentally is better. Here I'm showing my condenser and my reboiler. I'm not really needing one of those, so let's choose one without those. So this is the absorber. This is a different absorber. This is a different absorber. But these are the ones that are going to be my scrubbers. I can also do these for packed absorbers if I'd rather do that, but I will enter that. Now, one other way you can get these is you can also right-click and you can exchange the icon. And if you click on that, it will allow you to trade to one of the other models. Now, I need to connect each of these. These are my feeds, and I know this is going to look really wrong, but I'm going to add both of my feeds there. It will allow me later to identify where they go later. And I'm going to connect my sources here. Reconnect. I'm not sure why it's not letting me reconnect the, okay. I want the source, there we go. Okay. So I have those. Now I'm going to rename these to liquid and gas feed so that it will streamline things a little bit later. So now let's open up the RADFRAC block. And we're going to set this up this time for 5 equilibrium stages. But we want no condenser and we want no reboiler. Probably earlier you might have wondered why those options were even there. And then we'll set up our streams configuration. And this is really critical. So you need to make sure that you put the liquid feed above the top stage and the gas feed below or on the bottom stage. Okay, you've got to get those locations correct. And finally, we're going to come in and set our pressures. Okay, in this particular case, I need it to be at 10 bar. We're not going to do a pressure drop. We'll let it auto-calculate those. And so my block is satisfied. Let's come to our streams, and I need to specify my gas feed and my product, or my liquid feed. So my gas stream is going to be at 40 degrees C and 10 bar. I'm using mass flow rate of 100 kilograms per hour and mass fractions 98.2% CO2, 1.2% N2, and 0.6% acetic acid. And my liquid feed is 25 degrees C and 10 bar, flow rate of 150 kilograms per hour, and it's 100% water. Okay, so now then, if you run the simulation, and I can look at my results, I can look at my tower, I can look at my stream summaries. And what you'll see is that virtually all of the acetic acid is indeed removed, unless we were doing this on mass fractions, weren't we? And I have very, very little acetic acid left, okay, at the end. You can try reducing the number of stages, see what else you get there. If you change the number of stages, I do want to warn you that you have to go into your RADFRAC, and if I change this, for instance, to 4, then I need to also come in here and change the location of my gas feed. Okay, but you can do that and you can play with it until you find just the number of stages that seem appropriate. To get you 1 part per billion acetic acid by weight would be an appropriate goal here. You can try adjusting temperatures, so maybe try 80 degrees. Is that better or worse? Or maybe 20 degrees, go cooler. Play with these various compositions. You might try changing the pressure. Okay, you could change the flow rates of the liquid compared to the gas stream and see what it is that happens. So I thank you very much for your time, and this concludes this lesson in AspenPlus.